The disadvantage of Dijkstra's method was that it has to have all the positive weights. All the edges must be positive weights. That's the assumption it makes to start with. But when the weights are negative, then Dijkstra's algorithm cannot give the correct solution because it doesn't allow any distance from the source to get updated. So it is allowed only one updation. If it is used for further computation, then it is not allowed to update itself. So as an example, if you look at it, this from 0 we have 16 to 1 and 13 to 2. So we take up 13 and then 16. So from 13 we can continue, and then when it comes to 16, then 16 minus 10 becomes 6, but already we had a 13 here. So 6 should have been correct answer, but we have already fixed 13, therefore it can't be changed. That was a Dijkstra's method. But what we can do is, if there are n nodes in our graph, then the method Dijkstra's algorithm can be repeated n minus 1 times and we get the correct answer. So let's see how it is done. So to begin with, all nodes are marked with infinite except the source. So from source we can go to 1, which makes the distance of 16. From source we can go to 2, that makes the distance of 13. Earlier they were infinite, so they get replaced with these new values. Okay, then we have 13, so source work is over. 13, 16, infinite, infinite, infinite. So the next thing to update is from node 2. From node 2 we can go to node 1. So 13 plus 14 makes 27, but 16 is already there, so that's a better choice, let it be. Then from node 2 we can go to node 4. 13 plus 14, that makes 27, and earlier we were not having any value, so 27 is the first answer we know, so let's remember it. So node 2's work is over. Who is next? So 16, 27, then infinite, infinite. Therefore node 1 is currently at its lowest position. Therefore from node 1 you look at it. From node 1 we can go to node 2. So node 1's value is 16 minus 10, so that makes 6, which is less than 13. Therefore it is better to go to node 2 via node 1 instead of direct journey, because that's safer. Okay, so value of this has changed. So then what? 16 to 12 is possible. 16 to 3, so that makes 28. Better, definitely better than this. Okay, then so 16's work is over. Then who is next? 27, 28 and infinite. Therefore node 4 is the next option. So from 4 you can go to 3. So 27 plus 7 makes 34, but better answer 28 is already there, so let's neglect this. Then from 4 we can go to 5. 27 plus 4 makes it 31. Okay, that's a better choice, so let's remember it. So node 4 work is over. Then we are left with 28 and 31. So among them 28 happens to be the smaller one. So let's look at where all we can go from node 3 and see can we update anything. So from node 3 we can go to node 2. So this is 28 plus 9, that is 37, but node 2 is already at 6, therefore no change is possible. Then we can go to node 5, 28 plus 20, 48, but already it is 31, so no change is possible. So from node 3, all updates we tried, nothing is possible. Finally, we come to node 5 and there is no outward journey, therefore node 5 work is also over. So we have reached end of phase 1. So the values 0, 1 is 16, 2 is 6, 3 is 27, I'm sorry, 3 is 28, 4 is 27, 5 is 31. Now second journey. Let's begin our second journey. So all the previous things are no more required now. Right. Start the next. So from here we can go to this with 6. Then this is 6. This is 16. 16 plus then who is the next favorite? The next favorite is 6, 16, 27, 28, 31. Definitely node 2 is our next favorite. So from node 2 you want to go to node 1. 6 plus 14, that makes 20. 16 is the better choice, so let's neglect that. Then we can go from 2 to 4. 6 plus 14 is 20. Definitely it is better than 27, so let us improve this. Done. So node 2 is over. Then who is that? 16, 20, 28, 31. Therefore the next choice is node 1. So from node 1 we can go to node 2. 16 minus 10 is 6, as it is, no change. 16 plus 12, 28, no change. So 16's work is over. Then who is next? 20, 28, 31. So node 4 is the next chance. From node 4 you can go to node 3. So 20 plus 7 is 27. So definitely 27 is preferred compared to 28. And 20 plus 4, definitely 24 is preferred compared to 28. Okay, so node 4 is over. Then node 3 is 27, node 4 is 24. So who is better? Node 5 is the next chance. There is no outgoing, therefore there is no chance of correcting anything. Then finally node 3. So that is 27 plus 9 becomes 36. But 2 is already at 6, no change. 27 plus 20 is 47, but we are already at 24, therefore need no change. So finally we have new set of data, that is 0. For 1 it is 16, for 2 it is 6, for 3 it is 27, for 4 it is 20, and for 5 it is 24. Okay, let me improve all these things. So this is 16, this is 6, 3 is 27, 4 is 20, and 5 is 24. So let's begin our third phase. So again start from 0, that makes go to 2, so that says 13, but it is already 6, nothing to worry. Then go to 1, it says 16, it's already 16, so nothing to worry. that is 16 6. Okay, then what next? The third one says so start from 6 again, that is not 2. No, this plus the 14 will make 20. 16 is better option. 2 plus 6 plus 14 20 as it is, no change required. uh, uh, 6 is over, then node 1 16. So from here you can go down, so again getting 6, same result, go to the right, node 3. So 16 plus 12 is 28, but somehow you have got 27, so neglect this one. So node 2's node 1's work is also over. Then now we are left with 27 20 24. So next is 20. So 20 plus 7 is 27, 20 plus 4 is 24, so no change required. The next thing is 24, no outgoing. So then the last option is 20, this node 3, 27 plus 20, 47, but definitely 24 is better. 27 plus 9 is 36, definitely 6 is better, so nothing to be changed. So what has happened now is node 1 is 16, node 2 is 6, node 3 is 27, and node 4 is 20, and node 5 is 24. So you can see that the second step itself we have reached the final or a stable value, because the third one is also talking same thing. So you can repeat this totally 5 times, so 4 and 5 if you repeat as it is, so you get same values, no change. So when you want to put as an algorithm, yes, you can say that repeat this for n minus 1 times, or you can introduce some stopping instruction in the loop, so that if the same things are getting repeated, then you can break. So two options are there. So worst case, it can go up to n minus 1 iterations, or it can break in the in between if it reaches the steady state. So that's how we get a correct solution using Bellman-Ford method. Yeah, can't say that that's best possible. Let us try to see what would happen if this was a 4. Okay, let's begin our journey again. So 0, 1, 2, 3, 4, and 5. So our first step, you get a 0 here, 16 here, 6 here, then 28 here, 27 here, 31 here. In the second step, what will happen? Let me put them. Twenty-eight, 31. Okay. So when you get into second step, what would happen is first you will get chance of this 6, and 6 plus 4 will make it 10. Wonderful. Then 6 plus 14 make it 20. That's fine. Then what will happen next? Next is 10, 27, 20, 31. So 10 gets the chance. Then going to 1, 10 minus 10, it makes this 0. Then 10 plus 12, that makes it 22, a better option. Then that's it. Next 20, 22, 31. So from 20, if you take this journey, it is 27. So no good idea. 20 plus 4, 24, a better idea. So replace this. So we have 10, 0, then 22, 20, and 24. Done. Okay, what next? We have a 0 here, a 10 here. So when you start from 0, it says go to 1 with 16, but already reached with 10. So 10 is better choice. Then look for 2, it says 13, 0 is already there. So you say 0 is better choice. So neglect these two. What next? 0, 10, 20, 22, 24. So 0 is the next one to look for. So 0 plus 4 is 4. So better than 10. Good. Then 0 plus 14 is 14. Better than 20. Good. Okay. Then who is next? After 0, 4, 14, 22, 24. So 4 is the best. So from here, if you come down to 2, it is 4 minus 10, which says minus 6. And then from 1, if you go to 3, it says 16. Done. Then 14, 16, 24. So 14 gets the choice. 14 plus 14 plus 7 is 21, but we have already 16, so nothing to worry. 14 plus 4 is 18, so a better choice. Then next 16 and 18. So 16 plus 9 is 25, but this is already minus 6. And this is 16 plus 20, 36. That's already 18. So we are at it. So this is 0. That is 4. This is minus 6. And this is 16. And this one is 14. And this one is 18. Now if you just look at it, what has happened here is this has reduced by 6, this is reduced by 6, this has reduced by 6, this is reduced by 6, this is reduced by 6. Okay, don't know what is it. Anyway, let me continue. So again, this is 0, 16, this is 4, so 4 is better. This is 13, minus 6 is better. Then minus 6, 4, 14, 6, 18. So minus 6 will get the chance. So minus 6 plus 4 will make it 2. No, minus 2, sorry. Minus 6 plus 4 will make it minus 2. And then minus 6 plus 14 will make it 8. And that's it. Okay, then this is minus 6, minus 2, 8, 16, 18. Therefore, minus 2 is a better choice. So minus 2 minus 10 will make it minus 12. Minus 2 plus 12 will make it 10. And that's it. Okay, then this is 8, 10, 18. Therefore, 8 will get the next chance. 8 plus 7 is 15. So nothing to update. 8 plus 4 is 12. Yes, definitely it's updated. So then we get chance for 10. So 10 plus 9 is 19, but it's already minus 12. 10 plus 20 is 30, but it's already 12. So no changes possible. So the next one is 0, minus 2, minus 12. then 10, 8, 12. Now if you look at this, again a difference of 6. What is happening? What is happening is here, this loop, in one direction it is giving -10, and in another direction it is making +4. So total it is contributing to -6 in each round, and that -6 is dropping the whole thing every step by 6. So that means this n-1 will not help. So as you continue, it keeps going down and down and down. It will never reach steady state. So no steady state can be reached just because negative loop gain is there. Because of this negative loop gain, -10 plus 4. Last time what was it? It was -10 plus 14. So the total loop gain here was +4, a positive value. Therefore, it went into such a steady state after 2 steps. But because of this, it's no more getting into steady. We tried 1, 2, 3, 4, 5 steps also, but we couldn't 4 steps, and still we are unable to. If you try any more number of steps, it's definite that the next I can expect is -6, means this goes to -8, this goes to -18, and this goes to 4, this goes to 2, and this goes to 6 next time. Each time we get -6. So it goes on forever. So that's a problem. So that's a drawback of Bellman-Ford algorithm. It's a drawback of it. Okay, that's it for Bellman-Ford method. So ensure that before applying this algorithm, so look at all the loop gains. Anywhere loops are there, just make sure that the loop gain is always positive. So there is another loop we can see here. So 12, 9, 4. So that's a positive, doesn't make any problem. Or even you can see a loop here. So 9, 14, 7, that's also total add up will make positive, doesn't make any problem. The loop with a negative is going to make a problem. So that's Bellman-Ford method. So before applying, ensure that any loops are there. Then ensure that the loop gain is positive. If it is negative, just declare that because of this negative loop gain, this method cannot be used and it will never reach any steady state. So if you write a code on this, then so first line of the code is to ensure the loops and loop gains, and if you find any negative loop gains, just kill the process and say that this method cannot solve this problem. So that's it for now. So keep watching, many such issues to be discussed. Thank you.